Hello, I'm Graham Lewis, and in this short video we're going to look at two problems. The first one is how many even numbers are there with 4 digits when none of the digits repeat and all the digits are even. And then we're going to look at how many even numbers are there with 4 digits when none of the digits repeat, but the digits don't have to be even, which is a little bit harder. So we're going to do this an intuitive way first, and then we're going to do it using the rule of sum, and then we'll look at the harder problem after we've done this one. So let's just make sure we understand this problem. So the number has to have 4 digits, and all the digits have to be even. So an example could be 2, 4, 6, 8. Another example could be 8, 0, 2, 4. Notice that 0 is an even number. Now we couldn't have 0 at the beginning though, because if we had 0 at the beginning, really it would be a 3-digit number, 246. So that's not allowed. And we're not allowed to repeat a digit. So if I start with a 2, for example, I can't then have another 2. That would be not allowed. So that's what we're asking here. Let's do it intuitively. So if we're doing this intuitively, let's think about how many choices for the first digit. We can't have 0, but we could have 2, 4, 6, or 8. Leaving us with 4 choices. Now on the second time, one of the 2, 4, 6, 8 are gone, so you might think we only have 3 choices, but you'd be wrong, because what are we missing? Have you got it? Yes, 0. So because we go down to 3, because we've lost one of these, let's say we lost the 6, it could be any one of them, we're down to 3, but now we can include the 0, so we're back to 4 choices, because we've lost one, but include the 0 now. Then we're down to, we just lose one for the third digit, so down to 3, and then we lose one for the final digit, and we're down to 2. If we do that, we get 96. So that's the intuitive way. That's how I first solved this problem. However, there is another way of doing it using the rule of sum, and I'll let you decide which you prefer for this problem. I'm not going to say. That's just how I solved it first. Doesn't mean it's the best way. So here's the rule of sum method. In the rule of sum method, what you actually consider is we can fix the end value as 0, or 2, or 4, or 6, or 8, and consider them separately, and then add together the number of possibilities. So we find the number of possibilities, number of ways of arranging these 4 digits. If it ends in 0, then 2, then ends in 4, and then add them all together. So let's think of the 0 one first. So if we end in 0, I'm going to think of the last 4th choice. There's no choice. It ends in 0. Times 1, you have to put a 0 there. So, but remember that that is a 0. So I'm going to put a 0 there. Now, let's go back to our first choice now, because we've got 4 digits. Now, if we think of the first choice, we've used the 0 at the end, so we only have 2, 4, 6, or 8 to choose from, so I have 4 choices. Now, I can't include the 0 because I've used it. I've used one of these choices. Let's say again I'd use the 6, so I'm down to 3 choices. And then I'd be down to 2 choices. And so if it ends in 0, there are 4 times 3 times 2 times 1 choices, giving us 24. Now let's consider ending in a 2. Now if we end in a 2, of course, there's only one way we can end in a 2, but remember that's now a 2 at the end. So how many choices at the first one? Is it 4 or is it a different number? Pause the video, have a think. Hopefully you got it. The answer is, of course, 3. Because we've used the 2, so we can't use it again. We can only use 4, 6, and 8. And of course, we're not allowed to use 0 as the first number. Now let's think about the second choice. Now the second choice, we've used one of the 3 up, so we're down to 2 choices now, because we've used one of them up. But we can now include the 0, getting us back to 3 choices. And then we lose a choice, so we're down to 2 choices. And that gives us 18 ways of ending with a 2. Now let's do the same ending in a 4. And if you found that tricky, ending in a 2, we're going to repeat it for 4 so it will help. So if we're ending in a 4, remember we're ending in a 4 now. And so there's only one way of ending with a 4. Now let's think back to the beginning here, this first number. How many ways are there? So I've used the 4 up. So if I've used the 4 up, I can only start with a 2, 4, or 6. So there's 3 ways. On the second one, I've used one of these, 2, 4, or 6. So get rid of one of them. You don't know which one, it doesn't matter. You've got 2 possibilities, but now we can include 0 because it's not at the end. So I'm back to 3. And then I lose a choice. One of those 3 goes, doesn't matter which one. So I've only got 2 choices there, giving me 18 again. And in actual fact, you can repeat the same argument for 6 and 8. They're both 18 as well. And so by using the rule of sum method, I can add 24 and the 4 lots of 18 to get 4 lots of 18. You could do 18, add 18, add 18, add 18, of course, but that's quicker. And it gives me the same answer, 96. So now using critical thinking, you have to think, which way do you prefer? Do you prefer the first way, and why, what criteria? Or do you prefer the second way, and why, what criteria? Okay, now I'm going to go on to the harder problem. So now we've taken away the constraint of the actual digits being even, but it has to be an even number still. So now we're allowing numbers like 1, 2, 3, 4, which has 2 odd numbers there, and it's still even, but no digits can still repeat. If we look at another number, we could have 1, 3, 5, 0. We could have 3 odd numbers, and then an even number still, because it ends in a 0. So now let's try to do this the intuitive way and see if it works. So if you think about it, if we're doing it the intuitive way, and I'm thinking of what can go in these 4 boxes, I've got 9 choices at the beginning, because it could be any number 1 to 9. Now, obviously, on the second choice here, I could include 0, but one of the choices is gone. So because one of the choices is gone, 1 to 9, I'd be down to 8, but I can include 0, so I'm back to 9. One of the choices is gone. It's going well so far. I'm back to 8, lose a choice. It's this last one that's the problem. Now, 3 numbers have gone, but we don't know if they're odd or even, and that's the problem. So imagine this case, 3 were odd. If all 3 were odd, and I haven't used any even numbers, then my even numbers available would be all of them, 0, 2, 4, 6, or 8, and it would be times 5 at the end, wouldn't it? However, if I look at this example, I've got 2 odd numbers, and I've used 2 even. So the 2 evens are gone, and it would be a 3. So we don't know what that last number is, because it depends how many even numbers has gone before. So unfortunately, the intuitive way does not work in this case. So we have to use the rule of some way. So let me erase that, and we'll start the rule of some way. Now, before I start doing this, I'd recommend you pause the video and actually try this yourself, because you saw how it went with the last example. So try it yourself and then watch the video is the best way to learn. Always do mathematics. It's always really good to do it. So here we go. We're going to end in a 0. So remember, there's only one way of ending in a 0, and remember in your own mind that you've ended in a 0. So at the beginning, there's 9 ways, because we can't start with a 0. So we can start with the digits 1 to 9. Now, we can't include the 0 for the second choice because we've ended with 0 and we can't repeat it. So we're down to 8 choices because we've used one of the numbers 1 to 9. Now we lose another choice if it ends in 0. So it's 9 times 8 times 7 times 1, which is 504 ways of ending with the 0. Now let's think of the 2. There's only one way of ending with a 2. Now remember, 2 has gone. So that means you don't have 9 ways at the beginning. You only have 8, because you can't start with 0 and you can't start with a 2. So we only have 8 ways. However, now, when you think about it, one of the numbers has gone, the 2 has gone, and also we can include the 0, and another number has gone, whatever that was. So because a number went the first time, I'm down to 7, but because I'm now allowed to include the 0, because we're not ending with 0, I'm back to 8. Okay? I'll do it again for the 4 if you need. So then I'm down another one. So 8 times 8 times 7 times 1. And that gives me 448 ways in total. Now let's do it for 4. I'm hoping you're suspecting that it's the same, 448, like it was in the last example, which it will be. But let me explain it one more time. So here, there's only one way of ending with a 4 times 1. Now, if we think at the beginning, we've ended with a 4, so if we consider all of our digits, it could be 1, 2, 3, 4, 5, 6, 7, 8, 9. I've ended with a 4, so that's out, so I've only got 8 possibilities. Now I've used one of those possibilities. Doesn't matter which one you cross out, I'm down to 7, but I can include 0 because we haven't used 0 at the end, so I'm back to 8. And then I'm down 1, 7, and I get the same number, 448. So you should try 6 and 8, thinking about it. It's going to be the same, 448. So now we can write down the answer. So using the rule of sum, we add up all of these. So ending in 0 is 504 plus, and obviously we've got 4 lots of 448. And that gives me 2,136 ways of answering that badger. So, hope you enjoyed the video. Please remember you have to do mathematics yourself. Why don't you think about trying to solve a question like how many odd numbers are there with 4 digits when none of the digits repeat? And try that. Or maybe change it so it's a 5-digit number and do the same examples that we've done. Okay, thank you very much. Have a great day, everyone.